The broadcast is now starting. All attendees are in listen-only mode.
Good morning or good afternoon. My name is Mark Kovich, and I am a System Sales Specialist for IBM Rational Software. Thank you for joining our webinar today on creating combined simulations with Rhapsody and the MathWorks Simulink. Today presenting is Ron Felice, who is our Solution Architect for IBM Rational Software. Before we get started, I would like to mention that you are in listen mode only and that this session is being recorded. A question and answer session will be part of this webinar. Please type in your questions in the chat window of the session. You may ask your questions at any time during the presentation or demo. Many of your questions will be answered directly by me through the chat window. As questions are submitted, I will be sending them to Ron for his review and answer. Most questions will be answered after the presentation and demo during the Q&A session. The total time of this webinar will be a minimum of 60 minutes, but we may go over this time allotted depending on the amount of questions we receive. If we do not have time to get to your question, I will be posting my email address and phone number during the session so that you may contact me directly at a later time. Please note that Ron's presentation and this recorded session will be available, and an automated email will be sent to you with the appropriate instructions on how to retrieve the information. So with this said, allow me to introduce Ron. Ron, you may start.
Thank you very much, Mark. Hello, everyone. I appreciate you taking the time today to attend this webinar. I'm going to take us to a quick agenda slide here to give you an overview of what we'll be covering. I'm going to begin by describing the overall solution overview. This is going to include a discussion of the rational solution for systems and software engineering very briefly, and then specifically the solutions that we're going to be talking about today. Then we'll break into the integrated approach to model-driven development, and then I will show you the demonstration, which will include creating models in Rhapsody and generating in Simulink as well. So what we see on this slide is the solution that Rational is bringing to market for the development of systems and embedded software. This solution is based on our JAZ platform, which is a platform that's built upon a collection of open services. These services are developed in a series of work groups across disciplines that align with the life cycle. At the top of this chart, we see Rational Method Composer, which provides us with the ability to perform process authoring, allows us to capture best practices and integrated process guidance, things such as tool mentors that we can then publish and make available across the enterprise. Moving down the chart, we have in requirements management the Rational Doors solution, market-leading solution for requirements management, and this is part of our overall integrated lifecycle platform. As well, we have Quality Manager, the Rational Quality Manager, which is our quality management solution. It allows you to manage the overall quality process from planning through test case design and test script development, as well as traceability to the requirements. In the center of the slide, and one of the elements we'll be talking about today, Rational Rhapsody, along with the Design Manager, allows you to develop designs for your system and your software and to share those designs across the entire organization. And finally, the glue that holds all of this together is Rational Team Concert, our capability that provides for collaboration, planning, change, and configuration management across all disciplines. Taking a little deeper dive into one of the focuses of our presentation today, we'll be looking at Rational Rhapsody, our solution for model-driven development for systems and software. Rhapsody provides a graphical way to capture your system design and your software design, applying standard notation such as unified modeling language and systems modeling language, as well as architecture frameworks like DODAF, MODAF, and industry-specific languages such as AUTOSAR, or even providing you the extensibility to create your own domain-specific language in whatever domain that may be. Rhapsody gives you the ability to create these designs both from a systems engineering perspective, but also at the software engineering level, and then to generate complete application code in C, C++, C#, Java, and even Ada. The other solution that we're going to be integrating into this webinar today is from the MathWorks, and primarily we'll be focusing on the Simulink side of things, but certainly the MathWorks solutions are very complementary to what we provide in Rhapsody. So while we can describe the architecture very effectively with Rhapsody, if you have a need to do heavy math-based modeling, computational activities, as well as time-continuous control development, the MathWorks family of products will certainly be very powerful in helping you achieve this. Let's now move into the next session of this presentation, and that is the integrated approach to model-driven development. As I mentioned, this will include Simulink as well as Rhapsody. Simulink is where the physical plant modeling, as well as the modeling of the continuous control algorithms, as well as the complex math equation modeling is going to take place. What Rhapsody does to help expand the capability of Simulink is by providing a significant ease of architectural modeling, and this, of course, is enabled through the UML and SysML notations. These two modeling languages were, of course, built from the ground up to handle architecture, and because of this, provide a very capable platform for doing this. And then Rhapsody, through its integration with Simulink, allows us to integrate existing Simulink models, as well as we'll see in the demonstration, to generate Simulink model templates. There are three ways that we can go about integrating with Simulink. One is to import existing Simulink models into Rhapsody, and we can import any number of Simulink models. Part of the demonstration will show just how we go about achieving this. Second method is to actually create a model inside of Rhapsody and then generate S functions from these model elements, which can then be exported to Simulink and integrated into a Simulink design. And then the final method is to perform full plant modeling. And in this way, we can construct a complete plant model inside of Rhapsody, including Simulink models, creating Simulink model templates, and generating a full plant model then from that, which can then be executed and co-simulated on both sides, such that the behavior of the state-based behavior on the Rhapsody side can be visualized in tandem with the continuous behavior on the Simulink side. A tabular feature comparison of the tools to really sum up the capabilities here as we look at what things we'll be able to leverage depending on which workflow we select. So I'm not going to read through this entire chart. It'll be available to you in the slides when you receive them. From a system requirements perspective, we support MATLAB version 6 and up, as well as Simulink version 7 and up. And if you're using the import method, you will have to have real-time workshop to generate code from the Simulink model. On the Rhapsody side, we support this capability in the C, C++, and System Designer version of Rhapsody for execution. This is available in Rhapsody version 7.6.1 and greater. You also need to have a compiler in place that both Rhapsody and Simulink support. Certainly Visual Studio version 6, 2008, and 2010 are all supported, in addition to the requirement for real-time workshop and embedded code as a potential compiler. So now I will move over to the tool for the demonstration. I do have just a couple of brief slides after the demonstration to cover. So here we see Rhapsody. For those who are not familiar with the Rhapsody solution, the modeling environment is broken up into two primary panels. On the left-hand side, I have my browser. The browser is the hierarchical view into the model. If we move from the top down, I have my project level, and then a series of component and configuration combinations. If I'm constructing an application in Rhapsody, the component component will describe is where I will describe the scope of the application, and the configuration is where I will describe how the application is to be built. Moving down from that, the packages folder contains all of the work that I am going to create as part of my modeling effort. I create a series of packages to help me keep that work organized and easily identifiable. And then beneath that, the profiles. Profile is a standard extension mechanism for the modeling notation, and these profiles allow us to create domain-specific languages as well as enable integrations like the one I'm about to show you today. So while we're here at the profiles, I'm going to go ahead and add a necessary profile to this model, and that is the Simulink profile. Notice that I have a Simulink and then a Simulink in C profile. Since I'm working at the system design level, I'm going to use the Simulink profile. I'll bring this in, and this is going to allow me to create specialized types of blocks inside this environment that I can then apply Simulink models to. Here I have a block definition diagram on which I am going to specify the architecture for the system. And I'll create a system level block which will contain the rest of the blocks in this example. And I need to stereotype this block as a structured Simulink block. The application of the stereotype is going to allow me to change the way that this block is treated. As you can see, the system is now a structured Simulink block. I have two Simulink models that I want to bring into this, one providing some source input and one providing some response. So I'm going to have a driver, which will be my source, and I will then have a monitor, which will be my sink, if you will. And I'm going to use what's called a composition to create a relationship between the system and these blocks. Composition creates a whole part relationship, which allows these blocks to be considered as a part of a larger system. In this way, they could be subsystems and that aggregate up into a larger system description. As I mentioned, both of these blocks are going to be identified by Simulink models, so I need to begin by specifying them as Simulink blocks. And we have the option of integrating some default behavior. If we were going to apply the import method, at this point we would select yes, but for the purposes of this demonstration, since I'm going to be using more the co-simulation method, I'm not going to say yes. In this case, I'll say no. And I will then apply the same stereotype to the monitor. And again, no default behavior. I'm now ready to make the association from my blocks inside of Rhapsody to the Simulink models. By making these Simulink blocks, I have enabled the Import Sync Simulink Model menu item. Select this and then specify the Simulink model that I am interested in. First, grab this one. If I was using the import method, at this point I would specify the source code that was generated from Real-Time Workshop. Said I will simply select import sync. This goes out and finds my Simulink model and begins to parse it. I identify all of the imports and the outports and instrument my Rhapsody block with flow ports according to those imports and outports. A flow port is a sysml element that is used to specify data transport. You can see that the import and sync has passed successfully. And we see now that the block is instrumented with this flow port. the direction is out, and the type is RealT, which of course is a Simulink type. Let's go ahead and import and sync on this now. Select my sync model and click Open. I'm ready to import this as well.
Ron, I need to interrupt you for a minute. Some of the attendees are having difficulty hearing you, so maybe if you can speak up a little bit louder or put the phone closer to your mouth, that may help the situation a little bit.
Okay, great. Thank you, Mark. I will do so. So we are importing the final Simulink model into our overall design. Take just a moment, and this is completed. We can see that this block has now been instrumented with a flow port as well. This one is an inbound port of the same type. From these blocks, I can now open the model in Simulink if I choose. So I have some navigation capability. This will, of course, spawn the Simulink tool and open the model at the same time. What I want to do next is complete the architectural picture here. And to do that, I need to unite these two Simulink models so that I can create an execution. I will do that on an internal block diagram, which is another Simulink artifact, a SysML artifact that I use to capture structural architecture of my system under design. And what I'm going to do is I'm going to take these Simulink blocks, drag them onto this diagram, and create a connection between them. So I have my source and my sink, my driver and monitor, with their ports and the connector between them, enabling the communication between the two blocks. At this point, I am ready to generate the Simulink model. And this will take just a moment. So what it's doing is it is completely constructing a Simulink model that will contain both the driver model as well as the monitor model and create a connection between them. I see we have a question in chat while I'm waiting for this to finish generating. The question is, does it matter what project type is selected, or will this approach work on all project types? In terms of Rhapsody project types, this will work on both SysML projects as we have here. It'll also work on UML projects. So if I'm doing software design or system design, I'm able to use the same integration. And on the software side, it doesn't matter if I'm using C or C++. It's available to me in both languages. So now we see the Simulink model that has been generated from this. We can see that this has been generated based on the system block that I created. Here is the source model and the sync model. I'm going to go ahead and open the sync model. I have a scope in here I want to open so that we can see the execution. And minimize that. And I will go ahead and start the execution now. And here we see the output from that execution. So what this allows us to do then is to take the algorithms that we described in Simulink and unite them through the architectural capability of Rhapsody. Further, we could apply some Rhapsody architectural behavioral elements to this as well and create an integrated execution simulation. So that's one of the workflows. I'm going to take a moment now to close this up and run through a second of the workflows. And that is the workflow where we use Rhapsody and its architectural capability to create a Simulink model template, if you will. So I'll start by creating a new project. And I see we have another question. Rhapsody supports Simulink but not MATLAB directly, correct? Yes, this is correct. This integration is for supporting the Simulink design tool, not MATLAB directly. Okay, so my project is set up here. Let me go ahead and add that Simulink profile back in. And again, we're using that same Simulink.sbs. And I'll go ahead and put that system block on here. And again, this is going to be a structured Simulink block. Add in my blocks for the rest of the template. So I'll have a controller and also a plant block. And create the stereotype. In this case, when I create the when I'm creating the template, I want to use a structured Simulink block instead of a standard Simulink block, since I will be actually generating the Simulink model from here. So apply those, close this. We're going to add in a block definition diagram. And lay out my blocks. Once again, establishing this relationship to build up the overall system. And at this point, I am ready to create my, my architectural view. I need to add in a flow port here, and this will be represented again as an import or an output inside the Simulink model that's generated. So in keeping with the theme of the consistency here in flow, we'll have an output on the left and an input on the right. We'll call this out1 and make it a double. And let's go ahead and add another one. Call this one out2. And make this one a int. Okay, so there's flow ports there, and put a couple on this side as well to receive those. And make sure that these types sync up. Int and input. The next step I have to perform is to add an internal block diagram associated with each of these blocks. And this will be a blank internal block diagram. The only element that appears on here is a port. Get on that diagram frame there, show ports here. We can see the ports that are represented on the block. And I'm not recreating those ports. They're already there. I'm just making them visible. And we add a new internal block diagram here. And once again, selecting the frame and showing the ports. So we have imports on one block, outports on another, and those will be represented as imports and outports in the resultant Simulink models. So next I will generate a model from here. And while this is executing the process, I have another question here. The question is basically, what was the Simulink model that produced the output? It was a very basic model with a number generator that piped into an output. Nothing terribly complex. The purpose was really just to show how we could plug two models into a broader architecture and get them to collaborate in this way. Okay, so the generation of this model is complete, and here we can see that we have our outports, and we can begin then using Simulink to elaborate on this. In this way, we could use the Rhapsody model as a template for the creation of a number of different Simulink projects. Follow the same process to get the other one complete. But I think you get the picture there. So I showed a basic capability there, but the fact is that this can be extended. We can actually have multiple levels of architecture described in Rhapsody, something that's very, very easy to do with the Rhapsody design tool. And then we can generate models at the various levels. So we could have a situation where perhaps our plant model is decomposed into subplant models, which will then collaborate with each other, as well as accepting inputs from a controller outside of the plant model. Ultimately, what that would look like from a creation perspective is this would produce the controller as well as the plant, and then the plant A and the plant B, noting that the plant A would also generate input into the plant B. So we can describe a very complex architecture, something that Rhapsody is very good at, and apply the Simulink models to that architecture that we can generate from Rhapsody for Simulink. So this is the end of my presentation or my demonstration. I'm happy to take any other questions that you may have at this point.
Thank you, Ron. For the attendees on the call, the chat window is open. I don't see any current questions, so feel free to type in your questions to the chat window, and I'll be happy to forward them over to Ron so he can answer.
It's one other note while we're waiting for questions. For this demonstration, I was using Rhapsody 7.6.1 as well as MATLAB 2012A. But as a previous slide indicated, we do support from Simulink version 7 up.
Ron, I have a question coming over right now. Here it is.
Reports, can it handle Simulink bus objects? It's a good question, and unfortunately, it's one that I'm going to have to take offline. I'm not certain if it can handle the bus objects or not. I will have to follow up on that one.
So the person who asked the question, if you want to send me your email address, I'll go ahead and copy and paste your question again and send it directly to Ron so he can reply to you directly after the presentation later today. Okay, some other questions are coming in here. Let me copy and paste it. There you go. Ron, you see that question?
Yep. Any extended SIM plans? It's something that's being considered. We have a few things that we're looking at for consideration for the roadmap for this capability. This is a fairly recent capability that we've added, and so that is one of the things on the list for consideration. What I suggest is, and it's something that's very strongly considered then by development, is if you like the overall capability and would like enhancements, we have an RFE community, a request for enhancement, and certainly customer requests are very strongly considered. As a result of this feedback here in this webinar, I will be feeding back any things like that aren't already on the plan or are on the plan, and we're looking for customer interest. I will feed these things directly into that community after the webinar today. So, but as things like that arise, please do feel free to use the request for enhancement committee to submit those things. We have another one here. If an interface changes in Simulink, add input port, data type, etc., can that be propagated back to Rhapsody? The answer is yes, absolutely. You'll recall we had the import sync Simulink model. So there is a synchronization process there as well. It's not just a one direction. It updates whatever changes you have on the Simulink side into Rhapsody. So the addition of a port, the removal of a port will result in an update on the Rhapsody side to ensure that the two views are synchronous. Another question, I'm new to Rhapsody, but what advantage does it give you over architecting the system in Simulink and then linking the requirements to doors? It's a good question. So the architecting capability inside of Rhapsody is actually a little easier to manage, particularly with regards to signal propagation. But where you're going to realize even greater benefit is where you want to integrate with the doors requirements. Our linking mechanism to the doors requirements is quite powerful and is also bidirectional. I can actually visualize doors requirements inside of the Rhapsody environment and create extensive traceability across all of my design elements. So it gives me the ability to really break down that traceability and to actually visualize coverage information inside of Rhapsody in the form of a matrix. And then if we apply that integration with the Rhapsody gateway, which is one of our requirements interface tools, it allows us to do very easy coverage analysis and impact analysis. This is something that I would be happy to demonstrate at some point. So the person that wants that asked that question would like to follow up offline, I would be happy to go through what that would look like. The next question is how do you manage versions of the Simulink and Rhapsody models? On the Rhapsody and Simulink side, there is no internal versioning mechanism. And so what we have to do is we have to rely on external versioning tools. So Rhapsody and Simulink both support an SCCI interface, so the source code control interface from Microsoft. So anything that's compliant with that, of course, would be fully supported by both tools. In addition, they're both file-based tools so that you can apply any other non-SCCI tool and just manage those artifacts to the standard CM interface through a tool such as ClearCase or Synergy, Rational Team Concert, of course, as well as other tools like CVS or Subversion. So you would certainly apply that sort of technology to it, and then you would want to ensure that to the extent necessary, you track those together through change management as well, right? So don't just see on the tools, but also manage the changes together. Build up the synchronous change sets between the designs as you move forward. Next question, can I generate Simulink S functions from Rhapsody embedded code, provided that I can generate to Visual Studio or others Windows Target? Yes, we provide S function generation from Rhapsody using Rhapsody's code generation capability. And so you can construct a Rhapsody block or class or object, and then we have a stereotype called the S function block that you would apply to that, and then that enables the tool to generate the S function from that Rhapsody block. Next question is, do you have any examples of where this Simulink Rhapsody interface has been used? In other words, types of projects, follow-up, has it been used for multiple different linkages to multiple Simulink projects from a single Rhapsody model? So I've certainly got my exposure to this, and others within the organization may have other experiences. So I'll provide you with mine. If you'd like more, please do provide your information to Mark, and I'll have to get other references for you. But I've worked with a couple of automotive companies who have used this integration in order to link in algorithms that they've developed in Simulink. The couple of examples I can think of were the integration of some motor control algorithms into a software design, and then also with aerospace and defense company on the defense side. A company used the integration to take a simulation of, in this case it was tank turret control, and integrated that into a system design to flesh out the full system simulation. The next question is, how do you see the evolution of this capability in the coming releases? As I mentioned, we're currently looking at what future capabilities we should support. I would certainly expect to see things like extended sim come online as part of the capability. From an import perspective, we have only support for Simulink models at this point. I would expect to see that if you have a model that has some Simulink and some state flow, that ultimately we'll be able to support both of those. But today, again, it's just on the Simulink side. So to sum up the answer there, I would expect the inclusion of extended sim and state flow to be part of the evolutionary process of this capability. Next question, is the sync one way from Simulink to doors only? Simulink is master, or is it bidirectional? Simulink to doors. I'm not sure exactly what we're driving at there with that.
Ron, the person replied to me and actually said he meant the question to be related to Rhapsody, not doors. Does that help?
Okay, yeah, Simulink to Rhapsody. So the sync is from. So it's going to depend on our workflow, right? So if we're bringing the Simulink model into Rhapsody through the import workflow, then it's just Simulink into Rhapsody. We're not going to change the Simulink model inside of Rhapsody, right? Any Simulink updates will be done inside of Simulink. And so the workflow or the sync is going to be relevant to the workflow. So if I am going from Rhapsody S functions to Simulink, then I would do my changes in Rhapsody and again output to Simulink. If my import is from Simulink into Rhapsody, then I would make my changes in Simulink and bring them into Rhapsody. So the design work is done in the tool that sources the artifact.
Ron, there was a question in the beginning about the Extend Sim plans, and the person wrote back to me and made another comment that said that he was referring to the Extend Sim product. Does that clarify the question for you?
The Extend Sim product, that's not a Metaverse product, I believe, right? Can you clarify the source of the product? That might help.
Yeah. So the attendee who sent me the question, if you want to try to rephrase your question and send it over to me, I can paste it over to Ron, or if you'd like, I can contact you after the presentation. Just send me your email address. Okay. Sorry about that, Ron. If you want to move forward, that's fine.
Yep, no problem. I don't see any other questions in the queue there. Did I miss?
I think that may have been the last one. Let me check here and see. I've had a lot of activity going back and forth between myself and the attendees. A couple of questions came in. I've answered them for the most part, but maybe if you want to, since we have a few minutes left, to elaborate on it is talking about Doors Gateway. I don't know if you would like to just have a quick discussion about that, or if you have the capability of doing a demo. But I've indicated to a lot of the attendees that we do have a requirements management gateway tool from Doors into Rhapsody, and a number of people have asked to see demos of that at a later time. Ron, would you like to talk about that a little bit or comment about it?
Sure, absolutely. So the gateway is a Rhapsody add-on that allows us to connect to a variety of requirement sources. Our strongest integration through the gateway, of course, is Doors, but certainly not everyone stores the requirements in Doors, or doesn't store all of their requirements in Doors. A number of the customers that I've worked with have requirements in both Doors and Excel, or Doors and Word. And so what the gateway allows us to do is it allows us to identify these requirement sources and integrate those sources into the design environment. And in this way, we can then create coverage between design elements and requirements. This coverage information can be visualized in Rhapsody as well as in Gateway. But with the Doors integration, what's also very nice is that as I establish that traceability, I can propagate that information back up into the Doors module. And so the Doors module then would be populated with trace links between the requirements sourced in Doors and a surrogate module containing the design elements from Rhapsody. So if I have requirements engineers that are working solely indoors but need visibility to that traceability information, it would be available to them in Doors. And then for the designers, that information is available to them in Rhapsody as well as Gateway. So it's, I mentioned it gives us the coverage analysis view. It also gives us the impact analysis view, which is obviously very important as we start considering change requests to the requirements to see just how pervasive those changes will be, right, and measure the impact according to the areas of the design that are going to be impacted by that change. If we have time, Mark, I am happy to bring up a quick demonstration of that.
Okay, well, we have time. We have 10 minutes. And also a person wrote in asking about Design Manager. So if you know anything about that, maybe we can talk about that also. So go ahead with the Doors Gateway, and then if you want to talk about Design Manager after that, we can.
Okay, sure. I'm going to open up a model that I've got fleshed out a little bit that has some linkages into Doors. show you how this works out. So we've got another system design here. This one's the hybrid SUV model where the doors requirements have already been brought in. And I got just a little bit of lag on my computer here. But here we see the gateway is accessible from the Rhapsody menu. And I activate that and see if this brings up the gateway interface. The project is already set up in Gateway. We'll take a look at how those projects are developed. That will be the first step when associating a requirement set with our design. So as I mentioned, this is connected to Doors already, so when it starts up, if I haven't already logged into Doors, I don't have a Doors client open, it's going to prompt me to do that. And what it'll do is it will analyze the Doors module and what it knows about the Rhapsody project and see if there have been any changes since the last time it was run. In this way, what Gateway is doing is maintaining a constant image of both the requirements view as well as the design view and the relationships between them. And by maintaining this continuously, it allows us to ensure that we have the ability to synchronize our view here. It's a fairly small Doors module, a little over a dozen objects in the module. And here we see, this is the coverage analysis view. In the center window is our project artifacts. Briefly, I take you over to the project configuration window. And in the project configuration window, we'll see how we actually set up that project. So I have my model where my design is contained. I have my Doors module that contains the functional requirements. When I specify a requirement source, I have to specify a type of analysis as well. And this describes, this is where I describe what a requirement looks like in the source. And so we have, obviously, out-of-the-box specifications for what a requirement looks like, but it's entirely customizable. So you don't have to reformat your requirements to meet our out-of-the-box specification. And then I need to associate the requirement source with, in this case, a module. And what Gateway does is it brings up a module browser for me, and then I can select from that module browser the module that I'm interested in. I could have multiple modules linked in. That's no problem, but I do one per document here. So here we see the HSUV requirements that I've got linked in for my Doors database. If I want to add requirement sources, as I mentioned, I would have to add in another block here. So once I have the source in, I have to create what's called a cover between these two elements. And what this says is that my UML model is providing coverage of my functional requirements. Note also that we have a cover that is reflexive. In other words, it starts at Rhapsody and it ends at Rhapsody. And what this does is it allows us to provide coverage for requirements that we've captured during the design process. So one of the things that's expected is that as we do our design work, we will uncover requirements. These are so-called derived requirements. And as we capture those in the environment, we can then ensure traceability there. One of the things about capturing here in the design environment and our integration with Doors is that once we've captured them, we can propagate those up into Doors. So I've got my project set up. I can go back now into Gateway. If I make any changes here, it asks me to allow it to reanalyze the project. And what that does is that helps ensure again that Gateway is in sync across all of the artifacts that are linked in here. And then if we've made any changes, those will show up here. We have markers in the lower left-hand corner that show where things have changed. Of course, in this case, I've just done a reload, so there's no specific content change. We can see as I select these elements that are coming from the functional requirements from doors that in the selection window at the bottom, the specification appears. So here I have a requirement for the carbon footprint, and that's less than 75 parts per million. Performance, fuel economy, I can see the specification for that. If I want to see the requirements indoors, I can double-click on one of the requirements or right-click and select Navigate, and it will launch doors as it's doing here. For the purpose of this integration, you'll see that I'm using Doors 9.3, which of course is not the latest version of Doors, but works just fine with this. We actually support Doors 8.x and later. And so while this is opening, I'll show briefly the rest of the workflow. So we've got the requirements here. The next step would be to add those requirements to the model. Of course, we've already done that. They're in the model. I will take you over there to show you those. When you do an add to model for the first time, it adds in a package, as you see here, HSUV requirements. And finishing loading up doors there. And here we can see the requirements that are coming in. So for example, if I open up the fuel economy requirement here, we can see the hybrid SUV shall have 55% or better fuel economy than a typical SUV. So the same view of the requirement here as we had inside of Gateway. This provides a much easier workflow than having to move back and forth between tools and create even artificial coverage mechanisms. So once we've got them in our design environment, we can begin associating them with design elements. Part of that could be diagrammatic, where we could show diagrams of requirements. Here we can see how a power requirement might have been derived from power source management, and we can apply to this some rationale. So yes, you've captured a requirement, but why is that requirement here? Right, give me some rationale for the inclusion of that as a derived requirement. I see that a question has come in regarding rational team concert and change control. Rational team concert does have the ability to perform change control over Rhapsody artifacts as well. So let's go back very briefly. Here we can see that the doors module did finally open, and I have actually selected that that specific requirement that I navigated from the gateway. So it gives me a lot of capability for traceability as well as for navigation. Let me go back to the gateway here for a moment, and we'll go ahead and perform that add high-level requirements again. Just give you a glimpse into what that looks like. Again, I'm adding that to the HSUV requirements package. And I'll get a message back when this is done processing about the addition or modification of requirements. One of the other things to note is that these requirements obviously are coming from a high-level source. And so it's the one that's responsible for managing the requirements, not Rhapsody. And so if the requirement gets deleted from a high-level source, what we do through Gateway is we mark that as deleted in Rhapsody. The importance of that is that if we have requirements in the design environment, we're certainly going to create design elements based on that requirement. So if a requirement gets deleted, we want to be able to look at what's affected in the design. And so if we were simply delete that from the model, then all that traceability information would disappear, and we wouldn't know if artifacts in the design had been orphaned as a result. We certainly don't want to propagate design elements that are no longer required because the requirement has been deleted. So by simply marking it as deleted, we can do the impact analysis here. We can see if artifacts are no longer required as a result of the removal of the requirement. Here we can see that we have one modified requirement, none added, and none marked as deleted. We have modified the Rhapsody model, so Gateway is going to reload that model. So I'll go back to Rhapsody now. And show you some of the other visibility that we have here. In addition to the diagrams, we can also create tables and matrices, as I mentioned. So I can add a matrix here that allows me to visualize some of this traceability. And when I do this, I thought I had a layout in here. I guess I don't. So go ahead and create that quickly. The matrix views require a matrix layout. And so I'll just quickly create that layout, which describes the specification for what we're going to view. So let's say, for example, I wanted to ensure that all of my features or my use cases are traced to requirements. So I'll do a use case to requirement table, and then we specify what we're capturing in terms of traceability. And so typically we use a satisfaction dependency or a trace dependency to show that. So I just specify satisfaction there, and then now I've got that layout. I specify that layout as my template, and then give it a scope. And so let's go from the use cases to the HSUV requirements, and select OK. Now I can open up that matrix, and it shows me the entire matrix view. I had traceability established. I would see that here. I don't, but one thing I can do is I can begin to also establish traceability here. So, for example, operate the vehicle. Certainly one element of that is braking, another acceleration. And so this way I can build up my traceability using this matrix as well. I can also come back to my use case diagram, make this a little more visible here, and I can create traceability from this side. Let's dive into this a little bit because I've got some information decomposed here. And so say I want to add some traceability from this particular use case to another requirement. Go ahead and locate this in the browser. Here I see my accelerate use case. I'm going to add a relationship over to the requirement. Browse down in here. So as you can see, the matrix is a little more convenient for adding this traceability, but it can be added a number of different ways. And then so here we can see that this is now updated with that information. I can save the Rhapsody model. I can go back to Gateway then, and then it will update my traceability view and allow me to show that coverage information or even impact analysis information. So that's a quick overview of what we can do with Gateway and Rhapsody.
Thank you, Ron. The panel is open for questions. If anybody else would like to submit a question, go ahead and send it to me in the chat window. That looks like it's it, Ron. I don't think we have anything further. We've reached the top of the hour plus an additional 6 minutes, so I think that's good timing. With that said, we're going to go ahead and close out the call. We appreciate everybody's time as far as attending the webinar today. We know your time is valuable. Like I said, we very much appreciate that. Ron, great job. We appreciate your efforts in presenting and giving the demo today. So with that said, everybody have a great weekend. We're going to end this call, and that's it.
Thanks, Mark.